expressions. The question is, how can properties of operations be used to add expressions? Basically, this lesson is just another lesson giving us some practice on combining like terms is what it's going to boil down to. So that's probably good to get us back into the swing of things here. Let's go ahead and go to the next page and get started. So if we look at example 1, Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So if you'll notice, if we look at their costs here, costs, we have initial fees and monthly fees. Initial fees, a lot of times they may be a one-time fee, like when you first join something. You know, sometimes it's an annual fee, a yearly fee type deal. But, you know, it may be just a one-time thing, and then, you know, they kind of don't charge you after that first time. They're hoping you'll just stay with it, and then you won't get charged as much. Or maybe it's a thing where they'll hope you keep going because you don't, if you cancel, then you'll have to pay that initial fee again if you rejoin later. Anyway, if we look at this, they made bar diagrams for these two things. They did this for the health club and for the climbing, rock climbing. And you can see the dark blue is representing their initial fee, and then the light blue is representing their monthly fee. So if you look at this, we can write an expression for each of those. They did over here. So for the health club, they came up with 80 plus 50M, so $80 plus $50 a month. The rock climbing was 65 plus 40M, so $65 plus $40 a month. So if we want to find the combined costs, means we're going to add those together. So to add those together, basically it's just looking for like terms. So the book actually rearranges these. They get their like terms next to each other. So the 80 and the 65, they get those next to each other because those are like terms. The 50M and the 40M, they get those next to each other because those are like terms. If you don't want to physically rearrange these, if you don't feel like that's helpful to you, then you don't have to do that necessarily. Okay, we can look at this. We can say 80 and 65. We're going to add those together. That's how they got the 145 down here, by adding those. And then 50M and 40M, they added those together to get the 90M. This is a little bit simplified compared to some of the stuff we're going to look at. One reason is that everything's being added. There's no subtraction here, so we don't have to worry about, you know, do we add the numbers? Do we subtract the numbers? Is my answer going to be positive or negative? But other than that, this is kind of the basis of what we're going to be looking at in this lesson. So the Triet, Sophia, and Ollie each deposit $120 to open a joint account. They each make monthly deposits as shown. What expression represents the amount in the account after M months? So similar idea to what we just did here. The dark blue is their initial deposit. So they both put $120 in initially. And then you can see Sophia is depositing $150 a month. Ollie is depositing $135 a month. So we can make an expression here for Sophia's deposits. She's putting in $120 plus how much a month? 150. So that's 120 plus 150M. So 150 times however many months. And then Ollie deposited 120 plus 135 a month. Make sure you're getting this down in your books, please, so you understand and you can follow along what we're doing. Okay, once we've done that, technically we can go ahead and start looking for like terms that we can combine together. The book is actually physically rearranging to get the like terms right next to each other, and if you'd like to do that first, you can. Okay, if we get them right next to each other, we can see 120 and the other 120, those are like terms. They're just plain numbers, constants, we call them. Also here we have a 150M and a 135M. Okay, so whether you actually physically rearrange them like that or not, we are going to look to combine like terms together. So the 120 and the 120 we could add together would be 240. 240, good. And then 150M plus 135M would be 285M. Good. All right, so what this means basically is that all together, this is giving us an overall picture of what's happening. Combined, they deposited $240 at the beginning, and then combined, they're depositing $285 a month between the two of them. So example 2, what's going to happen here is that they're saying that we have more than one variable, and you might say, well, we just had one with more than one variable. We just had something with an M and something with an M. That's actually, it's two variable terms, but not two variables. Two variables is meaning that we're going to have more than one letter involved in this problem. So Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So profit is we take our income minus our expenses. The book's doing this a little bit different way. I guess since you have theirs to look at already, I can just mention to you guys a different option for how we can do this, and then you can look at what they did. Probably what I would do on this problem is look at what all expenses they had. So their ingredients, they spent $125 for muffins. They spent $92.40 for bagels. So we could actually just combine those together first, see how much they spent all together for their ingredients. Which would be $217.40. This would be our expenses. Okay, that's what all the ingredients cost them. And then we could look at what our income was. Well, if you notice, the muffins, they're selling for $2.40 each, and it says we're doing they sold M muffins. So you do $2.40 times M. The bagels, they're selling for $1.80 each, and we sold B bagels, so we could do $1.80 times B, however many bagels that is. That would be our income, is what that would represent. And again, for profit, we do income minus our expenses. So we would take that minus the $217.40. And you'll notice this is actually the same answer that the book has, other than they just put 217.4 instead of 217.40. Since we're talking about money, I'll go ahead and keep that 0 in the hundredths place there. The book is basically looking first just at muffins, then at bagels, and then they're combining them together. But again, I'm not going to be picky about what process necessarily you guys use, as long as it's a valid process. There's different ways you can do these problems. So example 3, they are promising us more complex expressions here, and you can see the difference there. It does look more complex. We're adding these together. The parentheses they have there, we actually don't need those parentheses. It's basically just saying I have these three terms here. I have these three terms here, and I'm adding those together. But the parentheses don't really have to be around those. Basically, again, we're just hunting for like terms that we can combine together and simplify this thing. So if you'll notice, our first term has an x in it. And then we got another term that's got an x in it here. So the 1/2 x and the 1/4 x. Again, the book actually physically rearranges and puts them next to each other. We know before we add fractions we have to have a common denominator. So with the 1/2 x and the 1/4 x, common denominator would be 4. So the first fraction, we'll multiply those both by 2. So that'll be 2/4 x plus 1/4 x is how they got the 3/4 x. The rest of this, and anytime they're subtracting, if you guys remember, you may want to add the opposite there, make your two sign changes. Might make it easier for you to see the signs of these things. Then they got their y's together, so -2y and -2y. They added those together. They're working together to get -4y. And then we've got -3 plus 5. They're battling it out. There are more positives by 2. So basically subtract 5 minus 3 is 2. More positives, it makes it a positive 2. And again, the book writes the answer like this. If you wanted to, instead of a -4y, you could have plus -4y would also work. One thing about the answer, if you have your answer in a different order, that's okay, as long as your signs are correct. Basically, what you guys will see when you do these problems, answers generally, they'll have the variable terms first in alphabetical order, and then they'll have the constant last. So on this problem, x comes before y in the alphabet, and then our constant is at the end. So that's just a trend you guys will notice as we do these problems. So if we look at the try it, we're going to be doing some similar problems here. They want us to find these sums. The first thing I would recommend as an option for you, if it helps, would be any time on the subtraction you can add the opposite. So I'm just going to go ahead and go through real quick. Anytime on the subtraction, add the opposite. Now, this part here, the -5.48p, that's actually not really subtracting. I mean, we can add the opposite there, but it's really addition in between there, so we don't really have to do that. So I'm just going to go through all these real quick and add the opposite so it's set up for us here when we go through it in a minute. And we're going to try and look at all 4 of these here today. Okay, always 2 sign changes when we add the opposite. Subtraction to addition, and then the opposite of the number that's there. Alright, so let's go ahead and look at part A. So if we notice on part A, again, I went ahead and added the opposite on the subtraction part. The first term has a C. There are actually no other terms that have a C, so I'm just going to go ahead and bring that down. There's no like terms with it. If you want to mark it somehow so you know you've accounted for it, that's fine. Same thing. We have a term with the P. That's the only one of those as well, so we can go ahead and bring that down. That leaves us with 2 terms, and both of those terms are constants, so we will be able to combine those together. So to combine these last 2 terms together, we'll notice that they are like terms again. They're both constants. They don't have letters next to them, so we can combine them. One's positive, one's negative, so they're working against each other. So we can subtract. So if we take the bigger minus the smaller, have to do some borrowing here. And we get 64 and 80 hundredths, or 64 and 8 tenths. We don't really need the 0 at the end. And again, we have more negatives than positives, so we could say plus negative 64 and 8 tenths, or you could say minus 64 and 8 tenths, however you want to do that. And kind of like the book's done, we've talked about it a little bit before. If you want to have, let's cut off part of my answer there. If you want to have parentheses around that, negative 64 and 8 tenths, just to make sure you don't lose that negative sign, that's fine. Okay, we'll look at part B. One set of like terms we have in this problem is the y's. We've got a negative 5y and a positive 5y. So negative 5y plus 5y, just like negative 5 plus 5 is 0, negative 5y plus 5y would be 0y. If we take 0 times something, it's equal to 0. So those basically just cancel out. You can put 0y there, but we don't really need it. So we can basically just say those cancel each other. So we also have two terms that have x that we can combine together. And in this case, they're different signs again, so we can subtract them. And basically, again, denominators are the same, so we know it's going to be something over 11. So if we just do 3 minus 2 is 1, and then the question is, which do we have more of? We have more that are negatives, so negatives win out here. So that would be negative 1/11 x. So our remaining two terms, we've got negative 3 and 5 5/10 are like terms. And so we can combine those. One's positive, one's negative again, so we'd be subtracting them. One thing we got to watch when we subtract these, we got to make sure our decimal points are lined up. The negative 3, I don't see a decimal point there, but we need to treat that as negative 3 and 0 tenths. If we put it under the other 5, we're treating it as just negative 3 tenths, which is not the same as negative 3. So we subtract, we get 2 and 5/10, and this time we had more that are positive, so that would be a plus 2 and 5/10. So this would be our answer for part B. So continuing on page 227, part C on the try it. We're going to look at our variable terms here. Alphabetically, B would be the first letter that we have alphabetically. That's our only B term, so we can go ahead and bring that down. Negative 14 and 2/10 B. I forgot on the subtractions here, if you want to go ahead and add the opposites, you can do that. Our only other letter we have is D. We have two terms that have a D in it. And so if we look at these, one's positive and one's negative. So they're working against each other, they're fighting each other here. And so that means we're going to be subtracting them. Remember, when you add or subtract decimals, you need to have your decimal points lined up. So the 3 4/10, you could put a 0 there if you want, make it 3 40/100. So when we subtract that, we get 3 36/100. And we can see here we had more positives than we did negatives. So our answer would be positive, so that would be a plus. .36 D. And then we can look at our constants. We got two constants, two just plain numbers here. And are they working together or against each other? Together. So we're going to be adding those together. And then we'll see what we got. Again, we got to have our decimal points lined up. So the 118 and 7/10, you can put a 0 after that. And we get 216 and 5/100. Those were all negatives working together. So we got a bunch of negatives here. So that's, you could say plus negative 216 and 5/100, or you could just say minus 216 and 5/100. None of those are like terms, so we should have this simplified correctly. We look at part D. Again, if we want to start by looking at our numbers, or our variables rather, M is our first variable. Before we do that though, let's add the opposite. Only got one spot to do that, looks like. So M terms, we got a negative 1/6 M and a 7/10 M. I'm just going to go ahead and bring these down here so we can see what's happening. Again, when we add or subtract fractions, we have to have a common denominator. Worst case scenario is multiply your denominators together. So 6 times 10, 60 would work. We could actually get 30 to work here as well. If you don't see the 30, go with 60. That'll work also. So 6 times 5 to get 30, 10 times 3 to get 30. So that would be a negative 5/30 M and 21/30 M. These are working against each other because one's positive, one's negative. So we would be subtracting those. So if we do 21 minus 5, whoops, that should be a 30, not a 31. That would be 16. We have more positives, so that would be 16/30 M. And then those are both even, so we know we can reduce both of those by 2. So if we take half of each of those, 16/30 would reduce down to 8/15 M. That takes care of the M part. We look at our other variable, we've got T's, and that's pretty straightforward there. We've got 5T plus 9T. Again, if it helps you to actually rewrite them next to each other, you can. If we just add those together, it's going to be 14T. I'm just going to bring that down, carry that down here on my work. And then we have two constants, two plain numbers. We've got a 3/8 here at the beginning, and we've got a 1/4. So we need to get a common denominator here again. Common denominator we could get would be 8. Okay, so that would be like 3/8 plus 2/8, and 3/8 plus 2/8, which would be 5/8. And again, we can double check, but none of these are like terms. So if we did this correctly, and we should be in good shape here. So the key concept on 228 is just kind of recapping what we talked about, looking for like terms and then combining those together. If we look at the do you know how number 4, Dylan says that 4b and negative 2b are not like terms because 4b is positive and negative 2b is negative. Is he correct?
No.
Okay, why not?
Because they have the same variable next to them, so that's what makes them like terms.
Good. Yeah, so we could say no. They have the same variable, which is just meaning the same letter, okay? So they are like terms. Okay, good. Number 5, Joel spent $28 for an internet data service and pays $14.50 per month. He spent $24.50 to join an online movie streaming site and pays $13.25 per month. Write an expression to represent Joel's total cost for both memberships after M months. So we look at this one. We can look at kind of two different parts here. The $28 he spent, that's kind of like that initial fee we talked about yesterday. And then $14.50 per month. I'm not sure what kind of internet provider he's with there. I'd like to find out who's charging him only that amount. But and then the $24.50 for the online movie, that was an initial fee again here. And then it's $13.25 per month. So if we look at this, like we talked about yesterday, if you want to, you can actually combine together your initial fees and your monthly fees before you work it out. The book was kind of doing two separate expressions and then combining them. If you want to just combine them first, that's fine. So if we look at this, we had a $28 one-time fee, and we had the $13.25. Oh, sorry. We had a $24.50 one-time fee, or initial fee. So we could actually go ahead and add those together. So we got $52.50, and then you can even see on the monthly bills here they've got their monthly charges. So the $14.50 and the $13.25. So $27.75 would be the monthly amount that they're paying. So if we write an expression for this, we could just say we've got $52.50 plus $27.75 times M. If you had that switched around, a lot of times you'll see it switched around from this actually. $27.75 times M plus $52.50. A lot of times they put the variable terms first. You don't have to do that. Just understand that's how they're going to put the answers a lot of times. If we look at number 6, we've got some N terms, some M terms, and some constants. They want us to add these together. So technically, if you wanted to write out first, we got 1/3 N plus 2/3 plus negative 1/6 N plus 1/6 M, just to show we're adding those together. Then it's just a matter of getting our like terms together. Alphabetically, M would come first here, so we only have one M term, so we could put that first, would just be 1/6 M. And then we look at our N terms. We don't have the same denominators. We got two N terms, different denominators. So we need to get a common denominator here. So 6 would work. So multiplying that first one, we could change that would be 2/6n. 2/6n plus negative 1/6n. They're fighting it out. The positives are going to win by 1/6. And then we only have one constant here, which is 2/3. So this should be our answer for number 6. We go to workbook page 55. We're going to skip around here a little bit. We're going to start out with number 9. So number 9, they're telling us the width of a rectangle and the length of the rectangle. They're wanting us to find the perimeter. Okay, so we need to understand what it means, perimeter. So perimeter is the distance all the way around a figure. Just like a periscope lets you look around, a perimeter is the distance around something. So the width, we've got 3x minus 1.5. The length, we've got 1.25x plus 3. We know on a rectangle, how many lengths do we have? 2. How many widths do we have? 2. Good. So if you want to draw this out so you can see what's happening, and then to find the perimeter, what would we do with our sides? Add them together. Good. So we'll be adding these together, then just looking for any like terms that we have that we can combine together. So any of these subtractions, if you want to add the opposites on those, you can. And we're just going to get our like terms together here. So we got 4 different x terms that we can combine together. Starting with the easier ones, with the 3's, we know 3 plus 3 is 6. $1.25 and $1.25 is $2.50. So 6 plus 2.50 should be 8.50, so 8.50 or 8.5x. And then we look at our constants, just the plain numbers. Again, if we want to start with the easier stuff, 3 plus 3 is 6. And then negative 1 and 5/10, negative 1 and 5/10. Think about $1.50 and $1.50 would be $3, so that'd be negative 3. 6 plus negative 3 would be 3. So this would be our perimeter. Again, the 0 is optional. You could put 8 and 5/10 x plus 3 would be fine also. So page 229, I'd like you to do numbers 8 through 19.